The law of flotation. In order to understand the law of flotation and investigate upthrust on a floating object, we arrange the apparatus as shown, where we have a test tube filled with some sand, a measuring cylinder with some water. So, after half filling the measuring cylinder with water, we place a clean dry test tube into the cylinder and add some sand to it so that it floats upright. We then determine the volume of water displaced, remove the test tube from the cylinder, dry it, and then determine its weight. The experiment is then repeated and observations made. The observations made in this case is that the test tube sinks deeper whenever sand is added. Furthermore, weight of water displaced is equivalent to the weight of the test tube and its content whenever sand is added into the test tube. From these observations, we state the law of flotation, which says a floating object displaces its own weight of the fluid in which it floats. Let's now look at an example on how the law can be applied. 1. A block of wood weighing 2.0 Newton is held under water by a string attached to the bottom of the container. The tension in the string is 0.5 newtons. Determine the density of the wood. So here we are interested in finding the density of wood. The same information can be represented as shown in this sketch, where we have some water in a container and then we hold a block of wood using a string, and the tension on the string is T. In this case, we have the upthrust acting upwards, while the weight and tension acts in the same direction. For that matter, therefore, we say that upthrust U is equals to the weight plus the tension in the string. Which is equivalent to 2.0 plus 0.5, giving us 2.5 newtons. By law of flotation, this is equivalent to the weight of water displaced. Therefore, mass of water displaced is equivalent to 2.5 over 10, since weight is equals to mg, and this is equal to 0.25 kilograms. Volume of water displaced equals to volume of wood. Implying that volume of wood is equivalent to mass of water divided by density of water, which is equivalent to 0.25 divided by 1000, which is equal to 0.00025 cubic meters. Density of wood, therefore, since we have already known the volume, is mass of wood divided by volume of wood. We know the mass of wood, which was given as 2.0 newtons. From there we can determine the mass. Since weight is given, weight is equals to mg, and therefore m is 2 divided by 10, which is 0.2 kilogram. Substitute there, we get 0.2 divided by 0.00025, which is equals to 800 kilogram per meter cube. Example 2. The figure below represents a block of uniform cross-sectional area of 6.0 square centimeters floating on two liquids A and B. The lengths of the block in each liquid are given. So the length of the block in liquid A is 2. The length of the block in liquid B is 3 centimeters. A further 2 centimeters of the block is left unsubmerged. So given that the density of liquid A is 800 kilogram per meter cube and that of B is 1000 kilogram per meter cube, determine the weight of liquid A displaced, weight of the liquid B displaced, and density of the block. Solution, starting with 1, where we are supposed to find the weight of A displaced. We proceed as follows. Volume of A displaced is equals to 6.0 times 12 cubic centimeters. Volume of A displaced is 6 times 2 cubic centimeters, which is equal to 12 cubic centimeters. Mass of A displaced is density of A multiplied by volume of A displaced, which is 12, we convert into cubic meters, multiplied by volume density of A, which is 800, and that gives 0.0096 kilogram. Therefore, weight of A displaced is equals to mass times G, which is equals to 0.0096 times 10, which is 0.096 newtons. Two, volume of B displaced, that is the area, the cross-sectional area, which is 6, times the length in liquid B, which is 3, and that gives numerical value of 18 cubic centimeters. Weight of B displaced is its volume times density of B times G, which is equal to 18 times 10 raised to the negative 6 to convert into cubic meters, times 1000, which is the density of B, times 10, and that gives 0.18 newtons. Three, density of the block. So from here, weight of the block is equals to weight of both liquids displaced. And this is the sum of the two values obtained earlier. Mass of the block is therefore equal to mg equal to 0.276 divided by 10, which is 0.0276 kilogram. We recall that volume is equals to the cross-sectional area multiplied by the height, which is equals to 6 0.0 times 7 times 10 raised to the negative 6 to convert it into cubic meters, and this gives 42 times 10 raised to power negative 6 cubic meters. Therefore, density of the block is equals to mass of the block divided by volume of the block, which is 0.0276 divided by 42 times 10 raised to power negative 6, which is basically 657 kilogram per cubic meters.